Hi everyone, in this video we're going to be going over zero knowledge proofs and why they're important. If you've been active in the Web3 dev space for a while, you've probably heard about zero knowledge proofs or ZK proofs, but what are zero knowledge proofs? Whenever I think of proofs, the first thing that I remember is all the math classes that I had in college, but don't worry, this will not be a math class. Zero knowledge proofs are essentially a cryptographic method or protocol that allow you prove that a statement is true without revealing any additional information. There's typically a prover, which is the party attempting to prove the claim, and there's a verifier, which is the party responsible for verifying that the claim is true. If you're wondering why we need zero knowledge proofs, let's go over a simple example of a situation where a ZK proof would be helpful. Let's say you were moving to a new city and looking to rent an apartment. You would have to visit a few apartment buildings and fill out applications and submit a lot of personal documents and information, all to prove that your credit score and income are above what is required to rent that apartment. What if there was a way to prove that you had all the information and met all those requirements without revealing the specific amount that you earn or any other private information? That's exactly what a zero knowledge proof allows you to prove. And so here's how it would work. In the above scenario, you would have to prove to the verifier that a mathematical statement which indicates you have sufficient funds and other credentials is true. There would be a series of interactions between the prover and the verifier. And if the verifier is convinced that the claim is true, then the verifier would verify your claim. However, in this process, the actual details of your income or identity would not be revealed to the verifier. There are certain requirements that a ZK proof has to satisfy, and they are: one, completeness, which means that the claim or transaction has been verified. Two, soundness. If the claim is untrue, then the verifier should be able to refute the dishonest claim or prover. And three, zero knowledge, which means that the only information revealed to the verifier is whether or not the claim is true. There are two main types of ZK proofs, which is the interactive zero knowledge proof and the non-interactive zero knowledge proof. Like the name implies, with the interactive zero knowledge proof, there would be a series of interactions in the form of tasks and challenges between the prover and the verifier each time the claim is to be proved by each verifier. And in the non-interactive zero knowledge proofs, there is no need for multiple interactions because the proof is created in such a way that it can be verified by any verifier. ZK snarks are a very popular type of non-interactive proof, and ZK snark is an acronym for Zero Knowledge Succinct Non-Interactive Argument of Knowledge. Yes, I know that was a mouthful. Basically, a ZK snark is a proof method that allows you prove possession of certain information without revealing the information, but also without interactions between the prover and verifier. And some applications of ZK snarks are ZK Cash and Tornado Cash, which are payment privacy applications. Some applications of ZK proofs include ZK rollups and the ZK EVM, which are scaling solutions for layer 1 protocols like Ethereum. They also allow privacy-focused protocols to offer their users private transactions. They can be used for anonymous authentication, and they can also be used by organizations which handle sensitive data to keep the data secure. And that was an overview of zero knowledge proofs. You probably know enough now to explain them to a friend. If you enjoyed this video, make sure to subscribe. Bye.